Hi, in this lecture video, I'll be discussing some of the very common terminologies that we use in chemistry, so make sure you are familiar with this terminology and understand what they mean. So first one, physical property. The word physical properties refer to the characteristic of a substance that can be observed or measured. So we can measure and we can observe it, then it is a physical property. For an example, the appearance of a substance is a physical property, the way how it looks. And the texture of it is also a physical property as well, or its color, or its odor. It smell good or smell bad. Its melting point, its boiling point, or density. Density of a substance is something that can be measured. So if we can measure it, it is then a physical property. And similarly, solubility. Is it soluble or insoluble in a particular type of solvent? Then again, and how soluble is it? So that's something that we can measure, and therefore it is a physical property. And also the last example, the polarity of a substance. Is it polar or non-polar? So all of this are physical property. And the word physical change, it refers to when we do something to it that now changes its physical form, but the substance is still there. So physical changes are basically changes that alter the physical form of the substance, the way how it looks, but the substance is still there. Then that would then be considered a physical change. So therefore, state changes are physical changes. When water solid change into water liquid, and when water liquid change into water gas, then now it's still a water, right? We always have water. It simply changed the way how it looks. A solid looks different than a liquid, and a liquid looks different than a gas, and they also have different melting point, different texture, different solubility, and so on as well. So basically, some of the basic property about these substances right here are being changed in this different physical state, but it's still a water. So it changed from water to water because the substance is still the same thing. It does, but only change the way how it looks. Then that would then be considered to be a physical change. And next, the word chemical properties. So chemical properties refer to the behavior of a substance or the reaction that it can undergo, because the types of reaction it can undergo tell us about the behavior of a substance. For an example, water can act as both an acid and as a base. So that is the chemical property of water. So water can act or behave as an acid or a base. So that is the chemical property of water. And a chemical change, it refers to the changes that destroy the substance, forming something that is new. So if one substance is changed into another substance in that process, then that would then be referred to as a chemical change. And chemical change are also referred to as chemical reaction. For an example, if water it changed into hydrogen gas and oxygen gas. So in this case right here, then we can see this would then be a chemical change, right? Because now water becomes hydrogen and oxygen. So it becomes something new. So water becomes something new. Or new substances. So therefore, it is a chemical change. And this arrow right here, sometimes we use arrow to represent a chain. If we draw an arrow right after to something, then that means we're doing some change to it. And in this case, because the formula of the substances are changing from water into all the substances. So therefore, this chain right here will then be the chemical chain. And sometimes physical changes can be used to detect chemical chain, but please remember that not always. For an example, if we were to take this bowl of sugar right here and we heat it up, we will begin to melt it and turn this into caramel. But now we know, so in this case right here, this chain right here going from here to here is then considered to be a physical chain. And the reason why is because the sugar is still there, right? It tastes sweet here if we were to eat it, and it still tastes sweet right here. So in a way, it tells us because sugar is still there. And the chemistry name of sugar is actually sucrose. So the sucrose is still there. And it changed from a solid state into a liquid state. So in this case right here, it is undergoing a physical change. Now, if we were to now take this caramel right here and keep heating this further, adding more heat, eventually we're gonna burn this. And now you can see a lot of smoke is being produced right here. And this smoke right here, or this gases right here, is actually due to the formation of water vapor and CO2 as well. And the rest, now it turns into this carbon solid right here. So going from this this caramel into this solid carbon right here, then this would then be a chemical chain. So it changed from a liquid back into a solid again. So in this case, it is a chemical chain, because now sucrose has becomes water and carbon and CO2. Now, so please remember that sometimes physical changes can be used to detect chemical change, but not always. So let's try some of this example right here to make sure that we know how to use this terminology. So problem number 8, classify the following as a physical property, a chemical property, a physical chain, or a chemical chain. So we'll go over some of this example right here. So first, A, mercury metal is a liquid at room temperature. So we see that it looks like a liquid, it is a liquid, so clearly we are referring to a physical property of it, right? So therefore this is a physical property. That something is a liquid. And B, sodium will ignite if added to water. So in this case right here, we are talking about the behavior or the tendency of how sodium will behave if it is added to water. So clearly, we are referring to the chemical property. And this statement will be classified as a chemical property. And now C, iron nails rusted. So rusted here refer to the fact that it gets combined with oxygen from the air, right? So something is happening to it. And in this case right here, it's not just a physical change that the color of the iron is changing from, let's say, black into like brown, because that's the color of iron rust. But in this case, it is also a chemical chain, because iron is now becoming iron oxide in this process. Okay, and maybe let's also try this example right here. So this diagram right here refers to what? Now clearly we know this is a chain, right? Because if we were to draw an arrow right after something, we're doing something to it. So we suggested a chain. In this case right here, so the substance is in green and now it's become green. So in this case right here, it is a physical chain. Before the particles got together, and now they're further apart from each other, but they're still there. So this is a physical chain. Versus with this one right here, in this case we're doing something to this, and take notice of what's happening. The white ball here and the blue ball are held together on the left side, and now on the right side, the white ball are now together and the blue ball are also together as well, but the blue and the white ball are not together. So this basically tells us that it producing something new. So therefore, this would then be a chemical chain.